Okay, today we're going to be talking about Statistics Homework 1A. A lot of terminology. I don't think it's going to be that difficult of a homework for you to do. My name is Carly McAvoy, by the way. And number one on this, I'm not going to, there's not as much writing on this, but I will just sort of let you know some of these without actually clicking on the answer, because once you hear my definition, you'll know. So what is a voluntary response sample? It is what it says. People respond voluntarily. So if you send out 1,000 surveys and you get 40 back, there's 40 people who volunteered to fill that out. And who are those 40 people? Well, typically they're the ones that have the strongest opinion. They're not going to be busy people who don't really care, because they're not going to fill it out. So voluntary response is a very tricky sample to use and get right. So we usually say there's just going to be a bias there. People that really care a lot, one way or the other, are the only ones that would respond. So not a good choice for a sample type. And then on the next couple of questions, they're asking you, is there any particular bias that might come up in this particular sample? Remember, a sample is the people that you talk to. So let's say you want to find out about everybody who is a student at SPSCC. How far do they drive to get to campus? That's your population. And then you talk to 50 students and you ask them, how far do you drive to get here? And that's your sample, those people that you actually talk to. And when we sample, we want to get a sample that is representative of the population. If you stop 50 people that as they got off the bus and said, how far do you drive? They were like, I don't drive at all. And then your sample might be like, I got 50 people, all of which said they drive 0 miles because they don't drive at all. So you have to get a sample that's representative of your population. So here's what this one says. The Washington University obtained word counts from the most popular novels of the past 5 years. Okay, so they took the popular novels and they counted the word counts. So, well, what Washington University isn't in the business of publishing novels, so it's not like they really have a reason to distort that. It's just the most popular could have come off the book list and they did it. So I don't think that that was a really biased. There's a lot of potential to be biased, because who cares if they find out that there was 10,000 words or 100,000 words. It doesn't make any difference to them. They just want to know that information. So there's no real bias going into that. So I think it's a pretty acceptable study. This one, survey of 590 subjects. Each was asked how often he or she played sports. The survey subjects were internet users who responded to a question that was posted on a news website. Again, you put up a question, you ask it. The people that answer are going to be the voluntary people that play sports and are happy about it and want to tell you about it. So there's a really good chance for bias in that, because it was voluntary and because that means you get the people that have like more interest. Okay. In a study of a weight loss program, 40 subjects lost a mean, and that's average, of 2.5 pounds after 12 months. Methods of statistics can be used to show that if this diet had no effect, the likelihood of getting those results is roughly 9 in 1,000. Does the weight loss program have statistical significance? And does the weight loss program have practical significance? So those are two different things. In general, we use 5% as our statistical significance. That is, if it would happen 5% of the time, more than 5% of the time by chance, then maybe it's not that significant. But if it would happen less than 5% of the time by chance, then we say that, wait a second, this happened. This usually doesn't happen, and yet it did. So this is number 4 here. So if you take the 9, this is by chance, they're saying it would happen 9 out of 1,000 times, which is 0.009. And since this is less than 5%, it is unlikely to occur by chance. So we say, you know, very unusual that that would happen by chance. So probably the fact this diet did make a difference. Statistically, it is significant, because people normally only like 0.9% of the population would have that loss by chance, and we had more people that had that loss. So it is statistically significant. But different is practical significance. If you were on a diet program and you stuck to it rigorously for a year and lost 2.5 pounds, would you be satisfied? I think people would say like, well, not really worth it. I mean, 2.5 pounds every year over a certain amount of time is going to do you good, but most people want a little more results than that. And so that means that if you worked at it that hard and didn't see that much significance, then probably not practically significant for you, even though statistically it is significant. So sometimes studies can tell you that this is statistically significant, but it doesn't really mean much for your life. If they had a medication that was going to get you over a cold twice as fast, let's say, and they could prove that, but the medication cost $160 to take it, practically not very significant then, because most people would just say, I'll just suffer with this cold for a few extra days, not going to spend $160 on a cure. So those are the kind of things we have to think about in studies, not just is it statistically sound, but does it have a practical use for our life? Okay, so let's go back to this one. I'm not answering these because you can read through them and answer them. So in this one it talks about 2 tables of data. One of these, I'll show you the data. You click on the icon to see it. One of the tables talks about weight of a freshman in kilogram coming into freshman year and then as they were leaving. And the second one talks about the X values in the table are nicotine amounts in different non-light menthol cigarettes. So that's what these are. And then the Y values are Y values are nicotine amounts in different king-size, non-filtered, non-menthol, and non-light cigarettes. So these things are talking about non-menthol. These are talking about menthol. So this first table has a meaningful association. That is, it's one person's weight from over 2 different times. But in the second one, these 2 different kind of cigarettes and their milligrams, so it's not as meaningful if we can just, it doesn't really make a sense to pair those up. One of them's menthol, one of them's not, or whatever. So it doesn't really make sense in the same way to compare those in that same way. So let's look at this one. We could do a similar one if you want after that. But in the table below, the X values are in weights in pounds of cars, and the Y values are the corresponding highway fuel consumption. So the X is the thing that we call, it's called an explanatory variable. So that's the one we're first looking at, like what happens when we change the weight of the car? Does it change the highway fuel consumption? That's what it looks like they're asking here, right? And that's what I said here is there's a relationship or an association between the weight of a car and its fuel consumption. That's the question. We're always trying to say, like, what's the question we want to ask here with this data? So we don't want to say, does highway fuel consumption of a car cause the weight to increase or decrease? That doesn't make any sense. That would make the fuel consumption the explanatory variable. But it's not. What's explaining that fuel consumption, we think, is the weight of the car to begin with. And then we don't want to say, does the weight of the car cause the highway fuel? Because we don't like to say things cause it. We can say there's a relationship, but we don't want to say cause. So that's always bad. We always want to avoid the word cause. And is there a relationship between the mean weight of a car and the mean fuel of consumptions? Well, we don't have means here. We have actual numbers. So we don't really want to look at the average. We just want to look at that. And so in this case, the relationship would be to, is there an association between weight of the car and fuel consumption? Yours will be slightly different, but several studies show that after drinking an energy drink, subjects had increased performance when running a marathon. A beverage company financed this research. What's wrong with the study? Well, when you have somebody who commissions a study to further their own product, then that's what we call a self-interest study, right? Deliberate distortion would be like they make the graph in such a way that it looks different. Voluntary response we already talked about. Partial pictures, they tell you a little bit, but they don't tell you everything. Precise numbers, I don't really want to go into that right now. We'll do that in the regular lecture. But so those are all things. A non-response means that there's a bunch of people who refuse to respond. But what we have here is a self-interest study because some company wanted to show that, produced to further their own cause. All right. Based on a study of car accidents in winter of men and women who live in different parts of the country, a researcher concludes that living in the North causes people to drive badly. Do you agree with this conclusion? Once they say something causes something else, you know they want you to say no. We don't like causes. We could say that there's a relationship, but we never want to say cause. So we might say that living in the North, people end up driving in the snow more, and then in the snow it's harder to drive, and so there's a relationship between the number of wrecks and the live where you live. But we don't want to say for sure that there's a cause. So it has to be one of the no statements, and I'll let you read that a little bit closer. It doesn't mean that there's no relationship. It just means that it's not a cause. We can't just say it's a cause. Okay. Let's see. A polling company reported that 29% of 1,013 surveyed adults said that the pesticides are quite annoying. Complete parts A through D. So what is the exact value of 29% of 3,013? So I'll show you the math work on this one, just in case you've forgotten how to do some of those things. So let's take a look at this. 29% of 1,013 is just 0.29 times 1,013. That's how I got the 293.77. The next thing they ask is that, would that be an exact answer? Well, no, because this is people, and we can't have 0.77 part of a person, so it's not an exact answer. They say, well, what could be the answer? If we rounded it up, it could be that it's 294. Or it could be 293, right? But it's in that range. Statistics is not about exact. It's about we're making a good guess based on what knowledge that we have. And then they said there were 699 of the 1,013 who responded a certain way. What percentage is that? And when you want to find a percentage, you take the first number divided by the bottom number. Just divide that and you get 0.69. So that's how you're going to do those problems on that homework. Let's see. All right. So an editorial criticized a chart caption that described a dental floss as one that reduces the chance of plaque on teeth by over 300%. What is wrong with this statement? If you have plaque on your teeth and you get it all off, you have lost 100% of your plaque. You can't lose 300% of your plaque. There are times when we use percentages over 100, but not when you're reducing something like plaque or the number of suitcases lost by an airline or something. They go to zero, they've reduced it by 100%. That's it. You can't go more than that. Okay, in this one, a researcher was criticized for falsifying data. Among his data were figures obtained from 7 groups of subjects with 20 individual subjects in each group. These values were given for the percentage of success in each group: 53%, 58%, 63, 46, 48, 67, 54. What's wrong with these values? Okay, so it's a little mathy thing here. But if you know a little bit of math, it's quite helpful. So what we know is that there's 20 people in his group, right? So if he's looking at the number of successes, it could be that he had 1 success out of 20, or 2 successes out of 20, or 3 out of 20, or 4 out of 20, or 5, 6, 7, 8, 9, whatever. But if you look at the percentages that go along with those successes, the first one is 0.05, 0.10, 0.15, 0.20, and I thought that was probably far enough for you to see the pattern. Is that all the percentages, when you have a 20 as a denominator, you always get these powers of 5, 10, 15, 20, 25, etc. So those ones that he got that were like 53%, 47%, like those don't make any sense, because we couldn't get those if we had that, because you can't have half a person being successful. So since all of our percentages are actually multiples of 5, then his research should also show only multiples of 5. So this thing where he has this is crazy. On your problem, you might get 18 or something besides 20. Write down 1 out of 18, 2 out of 18, or whatever, and see what that pattern is, and you'll start to see why it couldn't be. So what does it mean for the findings of a statistical analysis of data to be statistically significant? We just talked about that, but let me say it again. It's significant if the chance that it would happen by chance is really low. In other words, this, like, let's say you had a company that was saying, we can make you have the baby gender of your choice. So the sex could be boy or girl, but we can decide if you really want to have girls, then we can make that happen. And so they take 20 women and they give them all this drugs, and that they'll conceive girls. And when the babies are born, there's 18 girls out of 20. Okay, that would be statistically significant, because the chance of that happening just by chance is really low, because we would expect it to be around half. Maybe, maybe there'd be 7, maybe there'd be 13. There's some variation around 10, but it's going to be in there. When you start having almost all out of 20, that must mean their product must work. Statistically significant means that it wouldn't probably happen by chance. So that makes the statistics probably significant. Which of the following would be practically significant? So practically means that would have some useful application that people would want to emulate again. So I think I'm going to just let you read that and decide on your own, because I don't want to just give it away. But practically significant means that it would be actually helpful to society or to the people involved, right? What is the goal of learning statistics? When you're in statistics class, I am not expecting that when you leave here, you're going to have a calculator in your pocket ready to whip out whenever you read a report and calculate up and see if they did their p-values correct or whatever. And that's never going to happen. What we really want you to do, though, is to be able to look at the results of statistical studies and be able to ask some questions that would help you decide, is this study flawed or is it a good study? That's really what we're asking you to be able to do here. Survey questions can be misleading if they are loaded. And what does a loaded question mean? Well, a loaded question is like you come up to somebody on campus and you say, how mad are you about the fact that they're raising student fees? I mean, automatically you're telling the student you should be mad, right? That's a loaded question. So a loaded question is when you write it in such a way that it influences the outcome of the answer, because people are going to do that. It could be that it could be emotionally loaded, like, do you think that parents who love their kids would keep cell phones away from them until they're 15 or whatever? Like, that makes people want to answer falsely because they don't want to be like, I don't love my kid if I gave my 8-year-old a cell phone or something. So you can load questions in different ways. How do a parameter and a statistic differ? A parameter is a value, a numerical value that has to do with the population. And the statistic is a numerical value that has to do with the sample. And I talked about sample in that a little bit, but what number is this? Number 16. Something that's good to remember if you get confused on which is which, it's really easy if you remember the population is associated with the parameter, so that's PP, population parameter. A statistic is associated with the sample, SS. So we can always remember that way. So what does that mean? So let's say that I wanted to know the people that are taking my statistics course, just those people, what do they take for their how long did they take their previous math class? And if I ask everybody in the class and they all gave me an answer, and then I got the average of that, my average would represent a parameter because I asked everybody in the population that I was interested in. Okay, but if I took everybody, let's say I had 40 people in my course, and I just asked 5 of them at random, when did you take your last math class? And I got an average for that. That's just a small sample of the class, so that's a statistic. Why do we call this class statistics? Because it's usually impossible to talk to everybody in a population. If I want to know something about everybody in the country, I can't go talk to everybody in the country, so I have to talk to a sample, therefore we have a statistic, right? We don't usually talk to everybody. It is possible for a small group, but a statistic is what we usually have. A parameter would deal with the entire group. All right. Determine whether the given value is a statistic or parameter. A survey found that 25% of all respondents have jobs. So we're talking about a statistic there because it was a numerical measurement, which both of them are, but this described a sample, just the people that we talked to, the respondents. That makes it a statistic. Determine whether it's a statistic or a parameter. A homeowner measured the voltage supplied to his home on 315 days of a given year, and the average mean is 121.2 volts. Did he look at every day in the year? He only looked at some of them. I'm going to lead you to that. I want you to work on, just think about it. I don't want to give you all the answers. Sometimes the statistics program, the algorithms aren't as great as some of the other programs, so you get the same questions a lot. So I hate to answer too many of them because you learn by making your own guesses or educated guesses. What about discrete and continuous? All you have to remember for that is discrete data is data that's countable. So if I want to know how many cars are coming onto campus on a typical day, I can go out in the parking lot and I can count them all. There's a lot, but I can count them, right? But if I want to know how far is it from here to Seattle, that's continuous because it's not exact, even though we might say it's 60 miles, but it really might be 60.2575. There's a lot. If you want to get more and more specific, you could go, well, how many inches, and so it's a continuous if it's something like weight or temperature or distance, those kind of things where you have to use decimals, that's continuous. Discrete means that it's accountable, just like we're just talking about actual whole numbers of things. So I think that's what 19 and 20 are both asking you to do. And all you have to think about is this a countable thing? Even if it's huge, like 1 million, still possible to count 1 million things, right? If it's countable, we say it's discrete. And if it's not countable but uses some kind of decimals to describe them, then it's continuous. And that's everything in homework 1. I hope you have a great day, and I'll be doing homework 1B soon. Have a great one.